pieces of information for your data, 10 scores, and we found our standard deviation. We talked about what standard deviation is. But what happens if you have 35 pieces of information? And if you had to go through that whole process in which you had to find out the mean and then do all the subtraction from the score, subtract the mean, and then square it, and then add it, it would take quite a while if you had 35 pieces of information. So what we can do is we can narrow this down a little bit by using a frequency table. So what the frequency table is, if you were doing 5.2, where the frequency polygon is you set up a range that's going to be used. And I would only put so if I had 35 of them, I might only use, what do they use? They use six different intervals in order to do it. So let's have a look at the example. I'm going to go through the frequency table with you, and then I'll explain how this all works. So Rhonda works in the human resources at a car plant. She records the number of overtime hours worked in a month by 35 employees. So it goes all the way through the 35 employees. It says determine the mean and the standard deviation of the number of overtime hours to the nearest 10. So I need to find out the average of 35 people, and then I need to find out the standard deviation by subtracting all of those from the average, and then I need to square them, and then I need to add them, and then so following all the steps. So it's going to take some time. So instead, what she decided to do is let's develop a frequency interval, and let's only do 6. So if you look on page 117, they put the number of overtime hours. So anybody that had overtime hours between 0 and 2 hours. And then they did 2 to 4, and then 4 to 6, 6 to 8, and 8 to 10 hours of overtime, and then 10 to 12. And they did a frequency table. So I'm going to show you a tally chart first, and then a frequency table. So the tally chart works like this. For each one that you find inside that interval, you just mark it off on there. Okay? And then this is the frequency right here. So it works like this. The first number is 1.5. So where does that fall? Right here. I got one of those. The next one is, I'm going to work down. Okay? So I need somebody to help me here. I got 2. So here's the question Austin asked. And I don't like the way they set this up, this interval, but this is the way it works anyways. Austin said, well, I got a 0 and 2, and I got a 2 to 4. As long as you're consistent, it's okay. So either put them all on the low end or the high end, whichever. So I'm going to put the 2s in here. So if it's equal to the high number, then that stays in that one there, the one below. So I got 2. Okay, so what's the next one? 5. Keep going.
6.
Yeah.
8.5.
8.5?
Yep.
So that's here.
2.
So 2.
1.
1.
2.5.
2.5.
3.5.
What was the last one? 3.5?
Yeah.
Same here, yeah.
9.
9 is right here.
3.
3 is up here.
2.5.
2.5 is also right here.
1.5.
1.5 is there.
4.
4 is, oh, so yeah. Well, no, I have to put 4 in the one here. Right there, yeah.
8.
8.
4.5. 3.
Okay. Do we get the gist of this?
Yeah.
Okay. So this is what I call a tally chart. So all the tally chart does is allows me to just kind of quickly go through and mark off where each of these numbers all fall in the interval. So then at the end of it, I add up all my tallies. Well, they had 6, 12 in that one, 10 in this one, 3, 3, 1. 3, 3, and 1. Thank you. 3, 3, and 1. Okay. So at this point right here, so there's my frequency. Okay, we marked that off as F. Here's my frequency. Now what I want to do is I want to find the midpoint of the interval. So what is halfway in between 0 and 2? 1. Midpoint. I do this. That's my M value. So I got 1, 3, 5, 7, 9, and 11, right? There's my midpoints. Okay, so far? Again, I don't need you to write this down just yet. I mean, if you're diligently writing it, that's fine. So then the next stage at this point for our big standard deviation is to go f times x. Now what that does is when I multiply these together, okay, this allows me to find my total. Okay, so I have 6 people that got between 0 and 2. I have 12 between that, 10 between that, 3, 3, and 1. So if I add up all of this and find my sum of my fx, that's going to give me my overall total. Now yesterday, to find your average yesterday, you added all of the scores together and divided by the number of scores, correct? That's what this is doing right here. I'm adding all the scores together by multiplying how many I have by the midpoint to get that, and I'm adding them all together.
And you could do that?
Yeah.
You're allowed to.
Yeah, it's a shortcut for it, yes. So it's not going to be as accurate as what we were yesterday, but it's still going to get us what we need.
Like we did that on the test week, so we can put one.
Yes.
Oh.
Yes. Okay, so now I multiply these together, and that gives me a total. Now I have to divide it by the number that I actually did. So 18, 28, what is it? 35. It should be 35, right? We said 35. That's correct. Okay, so now I would take this number and I would divide it by that guy. All right? So that's how this all pieces together. That, when I take this divided by this, what am I actually getting?
Standard deviation.
No, not yet. No, not yet. I've already got my midpoints. If I take my, yeah, that's right. If I take my total, divide by my total number, what do I end up with? My average. Okay? All right. Keep that. Come back. Here we go. So, now we're going to go through our steps. So I'm going to split this board here. Okay? It's a little more complicated than it is. All right. So, first thing that I'd like you to do right now is write out your 7 steps here. Okay? So write out your 7 steps. Again, you're going to need this on your formula sheet, on your cheat sheet. If you don't put it on your cheat sheet, you're not going to be able to do this question, which will be worth quite a few marks because of the amount of work.
What chapter is this in?
once you're done with the steps, I also want you to put that chart on your page as well. So write out that chart as well, please, on the right side.
So the steps we yesterday was calculating standard deviation, and this is calculating it for if there's like
A lot of scores, yeah.
this table. Oh. Focus top. What's the third called?
Midpoint. Yeah, we put that as an X. Sure.
So when you find a midpoint, are you assuming that in that section, there's the equal number below and above the midpoint?
That's generally what midpoint is, right?
Well,
It's the middle number.
but if you have like a range of 5 numbers, 1 to 5, or 0 to 5, I guess. So like 3 is the middle, the midpoint. But what if you have a whole bunch like 4s and 5s, and not as many 1s and 2s?
Doesn't matter. It just has to fall in your interval. Yeah, I see. I understand your question now. Yes, you're assuming that it'll be somewhere between 26 and 30, and that they'll be evenly split closer to 26 and closer to 30. Yeah. Okay. All right, I'm gonna get rid of this guy for a second now. Let's focus on this, okay? So a phone company states that their mean number of calls per day for one employee should be 45. The maximum standard deviation should be 6. Should they hire more employees? So they give you the question. All right, so a legit question that we might want to find some answers to. Okay, so now let's get started on this. So the midpoint between 26 and 30 is what? What is it? 28. So I put 28 here. And then the next one would be 32, right? Oh, sorry, I miscalculated that. 31 to 35 is 33. 38, so I go up by 5, right? So 43, 48, 53, 58, and 63. So far, so good? Okay? See, realistically, I asked you to write all the steps, right? But if you just put that chart there and follow what you have in the chart at the top, that's all you actually need. Okay, you don't need to have the steps written out. If you just put an example with this chart here, You just have to follow. So what does F times X tell you? Multiply what?
Frequency times midpoint.
Frequency times midpoint. So 2 times 28. So we've got 56, right? Okay, 13 times 33. Calculate yourself. 429, is that what I heard?
Yeah.
Okay. 42 times 38.
1,596.
53 by 43.
2,279.
2279. 42 by 48.
2,016.
2016. 36, 53.
1,908.
1908. Good. 858.
464.
464. And 4 times 63. 252. Perfect. All right. So far, so good. Okay. So now we need to get all of this right here, right? Okay. So we haven't seen this right here. What does this mean to us?
Total
Is equal to what?
and I don't know what that is.
What was N yesterday? Yeah, that's right. The number of scores, right? In this case, the amount of data. All right, so we gotta add our frequency up. So add up your frequency, and what do we get? So let's go back up here. So I'm adding 2, 13, 15, and 42.
Yeah.
What is it?
200.
200, okay. So I got 200 here. Okay, now I need to add up my frequency times my X. Add up that column. 56, 429, add up all of those, please. 9,000 right on the nose. Somebody want to check that for me as well, please?
I got 9,000.
You got 9,000 as well? Awesome. Okay. So how do I get my average then? Brooklyn?
Divide it by 8. Or you divide it by the
You're right the second time. What does it divide by?
8
No,
or 200.
200. Okay, so this is my total. This is my total. I divided by my total number of data. So there was 200 that they did for this, okay? And now I get my average. What is my average? 45? Perfect. Nice even number. Okay, so far so good. All right, let's go up to here now. So what goes right here?
28.
Go ahead.
28 minus 45.
28 minus 45, right? Look at my symbols. Which one is X? Midpoint. What is my mean? 45. So 28 minus 45. So minus 17, minus 12, minus 7, minus 2, 3, 8, 13, and 63 minus 45 is 18.
So you're gonna have to do all these steps anyways. It's just that with this, you're making it into like
Intervals.
intervals. Yes.
That's correct. So I'm still following the same steps I did yesterday, yes. To answer that question. Okay? So now I square these numbers. All right? 17 squared is 289, 144, 49, 4, 9, 64, 169, and 18 squared is, you know it, no, 324?
Oh, 16.
18 square. Okay? So far, so good? So here's another one of those extra steps now. Because I have the frequency, I now need to multiply my F by my 289. So I'm going to multiply all my frequencies by that value right there. Okay? 2 times 289. Go.
578.
578. 144 times 13.
4752.
4752?
No.
No, that's wrong.
Yeah.
1872.
1872. It's okay. 49 times 42.
2015,
2015.
58.
58. Sorry, I have a fan above me, so speak loud when you give them the answers. You guys are doing great. 4 times 53.
212.
9 times 42.
378.
Guys are doing great here. 64 times 36.
So 304.
2, 3, 0, 4. 169 times 8.
1352.
And 4 times 324.
1296.
Fantastic. All right, so we're following all the way through here. What does this tell us to do now?
And the sum of F
Square.
times
You're gonna add them all together.
1.
Okay, so the sum of f times x minus x squared.
So add them all.
Just got to add that column. Right? That's already f times x minus x squared. So what do I got to do? Add these all together. Let's see. How do we do? Oh, I'll leave that up there so you can add them. So add those for me, please.
8,867. Or 10,050.
10,000.
10,050.
I don't know.
10,050.
Yeah.
Okay, missed one number probably only, Grace.
Probably.
Okay, it's all right. Good work. All right, to get the standard deviation now. Get the standard deviation. What does all that nonsense mean to us?
Divided by
200 and
Square root.
square root. So first thing you do is take that number divided by 200, and what do I get? I need to write it in here. Just
50.25.
50.25. Okay, and then square root that number.
7.089.
Okay, there's my standard deviation. There's my standard deviation. Now let's go up here and let's have a look at the question. A phone company states that their mean number of calls per day for one employee should be 45. The maximum standard deviation should be 6. Okay, do we need more employees? Yeah, because our standard deviation is larger, which means what to us? Remember, what does that mean? That our standard deviation is too large.
they are not close from the mean.
Yeah, that's right. Say that again too. They're spread apart more. Okay, why is that not a good thing in this situation? That means that there are too many on the low side, too far from the average. So we want to get it all much closer to the average, so each employee is closer to what the average person is. A large standard deviation, too far from the average. A smaller one means you're closer to the average, which means then that you have less inefficiency. All right? Sure, you're going to have more efficiency on the high end, but you're going to have too many people not pulling their weight. Okay? And that, in a nutshell, is standard deviation. Should they hire more employees?
Yes.
The answer is yes. Okay? Any questions about that? Basically, it's one of those things that you just have to follow through. Yeah, it is a lot of work, and you will have to do one of each of them on your test. One in which you do all of the data, one in which you do the intervals. Okay, you have to do it. But I'm also going to show you on Monday. I will show you how to do this on. Again, I would suggest getting a graphing calculator. I'll show you how to do this on the calculator, which it just takes seconds. All you have to do is enter in the data. Go ahead, Amarin.
When it's gonna be the test, it will have like say the F times the X.
No, you'll have to do your chart.
I will have to make it yourself.
Yeah, that's why I said put it on your cheat sheet.
Are you leaving yet this afternoon?
Okay.
It's okay. It's okay. We're here for you.
All right. Any questions about this guy? We're okay? All right. I want you to open to page 122 then, please. So I already started with this with you yesterday.
What paper?
Okay, sorry about that. I'm just going to save this. All right, so normal distribution. That means that, like I said, your data starts small on the ends and works up to the middle. So that means that the majority of your data is in the middle of the information. And you're given this, what we call a bell curve. And the bell curve is shaped like a bell, in which the middle is your average. So that means that the majority of your scores should be close to your average if your data is normally distributed. Okay? And then we break it down to standard deviations. So one standard deviation above and one standard deviation below. And then they give you a percentage on this. And that percentage is this, 34 and 34. So that means then that 68% of all your data on a normally distributed chart or information is going to be within one standard deviation of your average. Okay? Looking at the last question. I had an average of 45. They wanted all their employees out of the 200 to be within a standard deviation of 6. That means 51 to 39. Okay, so let's go back. The question said then that they wanted to have all of their employees within one standard deviation, or a standard deviation of no more than 6. Okay, so that's a standard deviation of 6. That means that the lowest they want to see their employees take is 39 calls. All right, that's what they're trying to do. For efficiency purposes, they're trying to draw that lower number in closer to their average. Doesn't matter how high it is. That's great. But they want that lower number to be closer in your standard deviation. Okay? When you get outside that and you get to 2 standard deviations away, this and this right here is 12.5%. and 12.5%. Right? Nope, my bad. 13.5. %. Okay. Now looking at those numbers right now, if you're within 2 standard deviations of your average above, that means then that 47.5% of all of your scores will be within +2 standard deviations. 47.5% below will be within 2 standard deviations. Okay? This is 2.35, and this is 2.35. And finally, on the outside, 0.15 and 0.15. You should only have 0.15% of your population or your data, whatever it is that you're studying, should be greater than 3 standard deviations of your average. Okay? Now, types of questions. I'm going to go through the first question. No, I'll do the example. All right. Ages of grandparents of Elaine's classmates were collected. So it's 60, 65, 70, 60, whatever. Does the data approximate a normal curve? Sketch a graph to help you explain. Okay. So what you would have to do in this question is create intervals. So what's the youngest of the grandparents in there?
56.
56. The young grandparents. What's the oldest grandparents?
Probably up to
56.
85.
That's not that young.
Isn't 80?
It's gotta be over 90.
85.
It's 85.
That's not. Or
The oldest is
90.
Okay,
90.
so there are, how many kids in this class? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So there's 28 people in this class, right? And the range was, what'd you say, 85?
90, 50.
90 to 56. So that's a range of, so if I go 90 minus 56, that's a range of 34. Agreed?
Yep.
So I have 28 kids and I have a range of 34. So I want to set up intervals. I want to set up intervals for this amount. And generally I want to go no more than 8 intervals. So they do 1, 2, 3, 4, 5, 6, 7. They do 8. And they set up their intervals between 55 to 60, 60 to 65, 65 to 70, 70 to 75, and so on. So they set up your intervals. You will have to set up one question in which you set up your own intervals. Okay? So to do that, I've got between 90 and 56, and I got 28 kids in the class. So I want to have maybe, I don't know, intervals between 5 to 7 in my ages. In this one, they do 55 to 60, so 5 years. They do the midpoint of it, and then they do the frequency. Okay, so I want you to follow through in step 2. Have a look at the top of the page in step 2. Okay, everybody's watching this now? They put the midpoint down, and then they do the frequency. And then they do a frequency polygon. So I'm going to do a quick frequency polygon here. So the frequencies are, they go up by 2. So 2, 4, 6, 8, 10, 12, 14, right? And the frequency between, so then down here they put the midpoints. I don't have a problem with you just putting the intervals down here. So I would write 55 to 60 there.
Okay.
And then I would write, what was my next one? 60 to 65, obviously, right? 60 to 65. And then in the middle of it, I would put my number. So my 1 is there. And then it goes, what's the 60 to 65? 4. So that's right here. And then 5, right here. And then it goes way up to 12, right? So up to here. and then 4 again, 4 again, and then 1, 1. So if I draw my frequency polygon, slight error. If I draw my frequency polygon and I look at it, it has to have the shape of that bell curve somewhat. Is it low on the outsides and high in the middle? That's basically what it's asking. Is that what it looks like?
Yeah.
If I were to draw a bell curve over it,
And what if it's not? Is that
then it's not normally distributed.
oh, okay? It's not
This
necessarily
is
not.
called normal distribution. So if it wasn't, it wouldn't be normally distributed. So I have that bell curve. This is a normally distributed amount of data. So that's all you need to do it. If you were drawing bar graphs, something like that. So it goes up and down, okay? That's a normal distribution. You could draw a bar graph for it. All right? Look at the practice question number 1. The ages of members of a seniors lawn bowling team club are normally distributed. The mean is 65 years old, and the standard deviation is 3 years. What percent of bowlers in each of the following categories? Okay, so what you have to do now is this. Again, you're going to want to put this on your cheat sheet because it's not given to you. All right? So you would put an example down so that you have your percentages. So the average age for a lawn bowling club is 65. The standard deviation is 3 years, right? So 68, 71, 74. 62, 59, 56. Okay. So the question says, what percentage of these 65, or of these lawn bowlers, sorry, not 65, but of these lawn bowlers are between the ages of 59 and 65? What percentage of these, of this club, is between the ages of 59 and 65? 59 and 65.
47.5.
Right.
Is every graph
It's 34 here, right? And 13.5 here.
every graph that's about those percentages?
Yes.
What's this?
So what's the answer?
47.
47.5. That's right. What about between 68 and 74? So I want between 68 and 74. What percentage of the bowlers are between the ages of 68 and 74?
58. Or 15.85.
What did you get?
15.85.
Okay, so I have 13.5 right here and 2.35 right there. You say 15.85. We agree or disagree with Amber? We agree. Not very difficult, is it?
I got 60.
So again?
No, never mind.
Okay. So this is your normal distribution. This is the same all the time. The percentages are always the same. Okay? All you have to do each question is write your average in and what your standard deviation is for each question. And that's it. Okay? Brooklyn, go ahead.
That's all you have to do?
For our question, like the senior one with all the students in the class, would it be easier if we did like 55 to 60 and then 61 to 65?
Sure.
Yeah?
Yep.
And that wouldn't affect this, would it?
All right. For Monday, I need you to finish to the end of 5-4. So you got all day tomorrow to work. 5-3 and 5-4. You need to be done 5-2. If you're not, you're behind. So that's a number of you in here that haven't finished 5-2 yet. Okay? Mostly because I've taken quite a bit of time to teach lessons. So get going on that.